Hi, I'm Steph Chavez. Today we're going to talk about Ultra HDI, also known as UHDI. So what is Ultra HDI? Ultra HDI is very fine traces in space width that are less than 75 microns or less than 3 mils. Well, the biggest thing we're seeing now in the industry is very dense compact designs, and in order to get to these smaller packages, when you think about micro BGAs, you're talking about like 0.5 millimeters or less, and in order to pin escape or to route such components with very tight pin pitches, you have to drop down to those tighter technologies, and Ultra HDI is the latest evolution when you think about how the industry is migrating to. A few more advantages that you can gain by implementing Ultra HDI is, reduce signal layer routing, so you can go from 12 layers, say, to 2 layers, as well as the amount of micro vias that are needed and the reduction in lamination cycles. So the challenges that you're going to run into, or that you potentially could run into, is the fact that you're reducing your layer counts and your spacing and your laminating cycles, which is great, but the issue is the capability of the fabricator. Can they do it? And you do gain, better capacitance and better inductance when you think about these finer trace and space widths. But the key here is, can your fabricator build to that small, tight technology that you're trying to implement? And this is why it's important that you work with them. So when it comes to DFM, Ultra HDI technology is no different. It's imperative that you collaborate with your fabricator from the very start, understanding what you're up against. If you're going to drop to these, below these 3 mil trace and space width, the first thing you have to understand is, what is your fabricator's capability? Can they fabricate at that level? And if so, what can you get away with and what you can't? And this is where it's important that you work very closely with your fabricator. So that way your board is designed for manufacturability from the very start. So when we think about DFM, especially in regards to Ultra HDI, working with your fabricator is key. You've got to work with them from the very start in order to implement Ultra HDI. When it comes to designing Ultra HDI technology, just because you can design it on your computer doesn't necessarily mean you should. And what I mean by that statement is that you got to work closely with your fabricator, understand what you're up against and whether it's doable or it's fabricatable, not just for that one prototype, but for mass production. So when we think about Ultra HDI and what application would that be good for or useful for, and so, when you think about smartphones, you think about automotive, you think about 5G communication, as well as RF design, this is the key, and this is where Ultra HDI will really come into play. So as Ultra HDI continues to unfold, we're going to continue to see emerging trends where the traces and space widths are going to get even smaller. The capabilities of the manufacturers are going to be more mainstream, so this technology will become more widespread than it is today, and we will see more implementation of this, so that way engineers can design packages that are tighter and smaller in size and dense and more complex than they have ever been before.